All right. My name is Puneet Thaplial. Until recently, was the CISO at Headspace. This is we are going to talk about the work we did at Headspace for improving privacy, including standing up a privacy operations center, and we'll talk a little bit about some technical bits, how we improve privacy by improving the underlying data storage architecture. So two parts to this. Myself, I'm going to cover the technical bits later in the later part of the presentation. But to start with, I'll hand it to Shobit to begin the presentation.
Thank you, Puneet. Hello, everyone. Good morning. My name is Shobhit. I am the Security and Compliance Director at Headspace. I am responsible for all things security, compliance, and privacy engineering at the current company.
Cool. Standard disclaimer, I haven't read this. Please follow the rules here for RSA. All right, we'll start with a quick pop quiz about the US Constitution. So, US Constitution is comprised of a set of amendments. So this quiz is about the amendment that talks about privacy. So everyone is familiar with the First Amendment, right? Right to free speech. Second Amendment, yes, right to bear arms. Who can tell me what is the amendment that gives all of us the right to privacy? A fundamental right to privacy. Which amendment in the US Constitution grants us the rights to privacy? Anybody? Sorry? No. There is no? Well, I got news for you. So it's the 14th Amendment. The 14th Amendment is about the right to due process, the right to privacy, and this becomes one of the foundational set of rights that many other fundamental rights are built upon, including the property rights. All of that comes from the 14th Amendment. So we should be all thankful for the US Constitution's 14th Amendment, where today we can say privacy is our fundamental right. So we'll get started. As I said, two parts to this presentation. The first one, we'll talk about the Privacy Operations Center. Everyone probably is familiar with Security Operations Center in the InfoSec world. What we did at Headspace was, because of our heightened needs for patient privacy, we also started this idea, we seeded this idea of a Privacy Operations Center. So that's what we're going to share with you. That's part one. Shobit will cover that. And then I'll come later on to cover part two, which is, again, for privacy, but technical bits. What did we innovate in the data storage architecture to improve our patients' privacy? So the two parts to the presentation, and I'm going to hand it to Shobit to get started.
Thank you, Puneet. All right. Before we jump into the presentation, how many of you have heard of Headspace? Perfect. We have like 90% people know what Headspace. But I'll briefly speak a bit about the Headspace as a business and then why we needed to have the Privacy Operations Center. I'm pretty sure many of you have known Headspace for the meditation content that we develop, the amazing characters that we have in the application. And that's all nice and beautiful. We have meditation, self-care content in the application that is used by 70 million people across the world. And then we have another application that's a B2B application, which is Headspace Care, which is something that you can use to chat with a coach, chat with a therapist, chat with a psychiatrist, and so forth. We have 4,500 enterprise customers on that front with 40 plus health plans and EAP partnerships. So if we talk about the scale of operations, we are available in 190 countries, just shy of 10 from Coca-Cola. They are available in 200 countries, I checked that. And then we have 100 million plus users who are using either Headspace or Headspace Care in some way or the other. So why privacy is so important to enterprises and Headspace? There are three main reasons to that. First is the legal and regulatory requirements. We operate in very restricted environment. We are a telehealth company, which means we are using or we are collecting mental health information from these members. And for that regard, we have to rely with many of the legal and regulatory requirements. Second is the company brand and reputation. Of course, this is one of the pillars to grow an enterprise. And then lastly, the recent rules in mobile app stores, which are upcoming all the time. I'll speak a bit about each of these. So legal and regulatory requirements, I'm pretty sure we all must have seen these logos and worked on these regulations at some point of our careers. GDPR, we have a huge presence in GDPR, and that's why we need to comply with GDPR. CPRA/CCPA, we have again, this is California rights. And like I mentioned, we are a telehealth company. So even though we only have mobile applications, we operate exactly like in hospital. We have to have a clinical officer, we have to have president and so on and so forth, which is the requirement of hospitals as well. And we are a covered entity under HIPAA, so we have to make sure that all of these regulations are under consideration. But this is just a tip of the iceberg. We are available in 190 countries, which essentially means we need to comply with the requirements of all these countries as the best as we can. The heightened privacy requirements from app stores. So Apple recently came out with this requirement that if you're allowing your consumers to create an account from the app store, you should grant them the ability to delete their account from the app itself. And similarly, Google came up with this requirement that even before somebody installs the application, you need to make sure that they are aware of the data that you'll be collecting. So if I go to any of the application right now, they will tell you, this is all the data will collect from you to provide services to you and then give you the best of our services. Financial and reputation losses. This is a slightly older slide, but FTC is enforcing a lot on the telehealth companies. These are just 3 examples. One of this example, the last one, Cerebral, they were recently again enforced by the FTC for malpractices and so forth. So if we don't have proper privacy and security practices, it may lead to additional enforcement actions from the FTC. And last but not the least, we have ongoing media scrutiny all the time. These are just the 2 headlines that I took from Google, why mental health apps need to take privacy more seriously. And then second one is a research paper on the privacy of mental health apps. There are thousands and thousands of studies going on all the time, and our friends at media are keeping us at our toes in making sure that we are doing the right thing for consumers. There are another independent reports from Mozilla, like Privacy Not Included, which are very well regarded by consumers and prospective customers. So we have a consumer base of 70 million users for Headspace, but we also have a huge offering on the B2B side. And when the security team on their end do the due diligence, they do go to all these different websites, check the privacy practices, compare to our peers who are offering similar services, and then they make the decision. With all that, we truly believe that privacy is an existential risk to healthcare companies. We can have all the amazing controls and privacy requirements in the application, but if we don't build the trust with our members and consumers, it will erode all the financial incentives, and we will have an existential crisis. There have been many, many instances where a single cyber attack either slashed 90 to 98% of the company's value if they were a public company, or if they couldn't pay the debt from the class action lawsuit, then they were just wiped out from the industry and had to file for the bankruptcy. And with all the efforts that we were taking with different teams, whatever we were doing, we realized that it was just not enough. We were having silos with security, privacy, compliance, legal, and product engineering, all these different teams. And we thought we are always falling short on some way or the other. So what we did, we came up with this concept called Privacy Operations Center with a single goal to bring all privacy, security, and compliance initiatives together. We had this in our mind that if we do just one thing right, it will help us a lot to streamline all the different requirements we are getting from the external regulations or the media outlets or the app stores and so forth. So that was the genesis of Privacy Operations Center. And what constitutes a POC is primarily 4 pillars. The first one is governance and management. This is the first pillar of Privacy Operations Center. The second one is partnerships across different teams. We'll talk about that. The third one is tools and processes that we'll need to implement. And lastly, the awareness, both internal and external, on the privacy practices. And if we tick each of these 4 pillars of privacy, then we'll have our Privacy Operations Center. All right, before moving into the meat of the presentation, the quick pop quiz. Anybody knows the cost of processing a single DSAR request? DSAR are data subject access request, GDPR, CCPA. Any guesses? What's the cost of that? way higher than that. It's $5,350 in terms of your tooling cost, in terms of your cost of your resources, in terms of the time that you'll spend verifying the identity and so forth. So that's the cost of processing a single DSAR request. Now, when we talk about DSAR, there are 2 main components. First is the strategic, and the second one is classification. The strategic component is framework, policy, procedures, and stewardship. When we speak about frameworks, we have all these amazing guidance from GDPR and CCPA and other regulatory bodies. On the basis of those, we can develop our own policies and procedures on how to process DSAR. And of course, we need any steward within the company who will be able to sponsor the entire project. The second piece is classification, which drives the entire DSAR, which includes organize, store, protect, and maintain the data. So this supports the strategic part. And when we speak about classification, more often than not, we try to squeeze all the data that we have, regardless of their type, in each or in one of these 4 categories. It could be public, confidential, restricted, or highly restricted. This is coming from NIST. And when I spoke to many of my peers across the industry that what they are doing to store their, or what's the classification they are having for PHI, or how they are processing DSAR requests and so forth, it always was squeezed into one of these 4. And we realized that that's not a good model for Headspace, given we are a very different company from other healthcare industry companies or other industries, other companies who are in meditation and so forth, given we have a component of care as well. So we created our own data classification, which was the foundation of entire DSAR. We have 2 classifications. First is parent and the other one is child. We have 6 classifications in parent, which is pretty standard: sensitive, private, customer confidential, company confidential, research, and public. And then of course, in the child classification, we have PHI, health, and so on and so forth. The key thing here is, even within GDPR and the US regulations, they have to have a different segregation. And I'll give an example. For religious beliefs, HIPAA doesn't have an exclusive say on what religion belief should be classified as. But in GDPR, they do have a separate classification for that. Similarly, for people who are looking for post-maternity trauma or content such as that, we don't have a classification for that in the US, but GDPR do have that classification as special category data. So we came up with this classification, and we spoke to our engineering teams that this is how we are going to classify all the data that we are receiving from our consumers, both D2C and B2B. But for any of us who did ever try to do classification, we know it's extremely, extremely hard. And even with all the automated tools that we can have, it's a very hard problem to solve. So classification is inventory, incomplete without inventory. I can do all the amazing classification, but if I don't inventory my data or label my data, it's not going to work out. And complete data inventory is extremely hard. So When we started this program, we started from the very basics. We realized that if we hit this 9 columns perfectly, it will help us a lot in tracking the inventory problem and then ensuring that whenever we are receiving any deletion request, we are processing those to the best of our abilities. This is my favorite slide of the entire presentation because it shows the amount of work we did and the results as well. This speaks to the second pillar of the Privacy Operations Center. So we pay a lot of emphasis on shifting security left in terms of DevSecOps or in terms of threat modeling. But what about shifting privacy to the left or legal to the left or compliance to the left? That's something which is often missed. And we developed this process called product risk review process with partnership with our product team, engineering team, legal team, privacy team, and the security team. Now, every time we have a new product feature to be released in Headspace or Headspace Care, and we create a PRD, that PRD drives the tech spec, and both of those are submitted to review to legal, privacy, and security team. The legal team does their own magic, making sure we are complying with all the legal requirements. Privacy team does their own magic in making sure that we are complying with all the privacy requirements. And then of course, security team, which is my background, we do the threat modeling, ensuring that all the tools or features we are developing are secure and tested before we roll that out. We summarize all the findings that we have from these reviews, and then we create a report. We send that out back to the product teams. They make the necessary changes, and even before a single line of code is written, this is what is happening in the background all the time for each of the PRDs, which has alleviated a lot of our pain of tracking these issues at the tail end. Once we develop the feature, then we do an internal pen test for all the major features, and then we make sure that we are securing that feature as much as we can before rolling that out to 100 million users across the world. Right. Okay, we talked about governance and management. We talked about partnerships, which was a critical part of the Privacy Operations Center, but we also wanted to shift privacy left and right. And this is where we partnered very closely with the engineering teams. So we have a lot of DevSecOps tool which we can use to shift security left. But for privacy, there are many tools which we can use to shift privacy to the left as well. So now we have a dedicated tool which scans all the code in our GitHub at all times. And every time a new PII request is made, in the code itself that we are going to collect PII/PHI, we ask for a justification that why do we need to collect this level of information again from the consumers. The developer justifies that. If they justify, then it goes for approval, and then they can collect or ask for the additional information. The central part of the shifting security left and right is the classification and labeling. If we collect data in all our GitHub repositories, but in the backend, if we don't do the proper classification and labeling, this is going to be really hard, and we won't be able to keep our promises. And lastly, once we take the left center part, then we jump to the right, that who should have access to the data, which is our data governance. So even though we are collecting this data, we are being very mindful in collecting all the data from consumers. We want to ensure that when the data is in the Headspace systems, that data is only available to the restricted users, only for the purpose that they need. And the last part of POC is privacy awareness and training. And we have 2 dedicated programs for this. One is internally facing and the other one is externally facing. For internally facing program, we have dedicated Headspace security and privacy training. It's not just a privacy and security training, it's like a rundown of all our security and privacy practices, plus compliance requirements, plus legal entities and so forth. So this is required to be taken within 30 days of joining and all the amazing stuff, but it speaks in detail about how everybody should treat PII, PHI when they join Headspace and what they should be doing. We have monthly office hours with the CISO and the DPO, so anybody can come in and ask for any questions related to privacy practices. We have dedicated Slack channels for ad hoc queries. We have privacy intranet and form. And then lastly, the master privacy FAQ, which is a 15-pager charter. It speaks to everything related to our privacy practices. And then externally, we are currently building this trust center, which will host all our high trust certifications, SOC 2 certification, HIPAA, compliance, GDPR, CCPA, all that amazing stuff, along with a very easy to read privacy policy and terms. So we are being very transparent about what we are collecting and so forth. And lastly, we'll have a huge a list of all the, not a huge list, but a list of all our sub-processors, along with the way we'll use the data. So this is the final pillar of our Privacy Operations Center. And just like SOC, where you have this dashboard giving alerts to you all the time that, hey, this is an alert from application A, we should look into it, and so forth. We have a similar dashboard that we present to the exec team. Here, we track all these different pieces that we talked about, right from DSA requests to privacy by design, to privacy SAST metrics, and then privacy training completions by team. With that, I'll pause my section and I'll hand it over to Puneet.
Thanks, Shobit. That's amazing. So I hope you got a chance to get this sense of how important privacy is for Headspace and how much innovation we have done to seed this program called the Privacy Operations Center and the beautiful dashboard that Shobit and team are building. We'll switch gears. As I promised, this presentation is two parts. The first part was about GRC-driven activities for Privacy Operations Center. The second part is more technical, so just strap on for technical details. So as part of our privacy initiatives, we realized that the data that we store in our databases is extremely sensitive, more than any other organization. For example, we store psychotherapy notes. Those are very, very sensitive, very private. So we had to do something innovative to protect that. So that's what this section is about. We internally codenamed this project the Vault Architecture. It's a privacy-focused data storage architecture. So I'm going to deep dive into that in the next few slides. So first of all, why do we even need the Vault architecture? So as I said, there are extreme privacy requirements. For a mental health care company, it's more than regular healthcare data. It's about your most private information that you share with your therapist and psychiatrist. And we store that. So it's our responsibility to do something more than regular to protect that data. In fact, it's so important that HIPAA has a separate call out. HIPAA being a 1996 regulation, still even from that time has a call out for psychotherapy notes that we need to really take extra precautions to secure this. So we built something. And the most important reason is this data is kind of quote unquote for clinicians' eyes only. It's not meant to be shared. It's not meant to be processed. It's not meant to be used in your AI models and so on. So it's very, very private data. There are a couple of more important reasons why we had to invest in building the Vault architecture. One is the malicious insider threat. So we feel that we have so much important data, it can lead to cases where our internal folks who have access to the data might have a lot of curiosity, peeking and poking, and we need to do something more to protect from insider threats. Think of a celebrity scenario. If a celebrity kind of starts tweeting that I'm using Headspace for therapy, the curiosity inside the organization would be so high that we, from a security and privacy team standpoint, we want to make sure that we prevent any peeking and poking. We don't want to be reactive. We don't want to put more monitoring and find out. We just want to prevent any possibility of peeking into any patient's data. So that's one. And then the last bit is as important, which is how do we prevent like mass exfiltration of psychotherapy notes, right? Most of the mass exfiltration happens because all data is stored in clear text in a database, and if a hacker is able to get into your environment, they take all of that data with them. So how do we build an architecture where it takes care of this thing, where instead of the hacker getting everything in one place, they have to go and break one clinician's laptop to another clinician's laptop to another clinician's laptop to get all the data. So these were some of the concerns why we kind of said it's important to invest in building the Vault architecture. But that it doesn't come for free, right? Like if you add more security, something has to give. So we had to compromise on some things. So here are some of the prereqs. The most important prereq for building a Vault architecture is that data, you should have no functional use case to do a full text search across all of that data in your database. If you need that kind of feature, which is very common, then Vault architecture is not for you. And then second is extreme isolation. This is where those clinical data elements really, like there is no post-processing need for those data. There is no analytics you need to do on it. There is no AI model that you need to train on it. It kind of sits there for clinical purposes only. So if these are the prereqs, if you don't meet these prereqs, Vault architecture doesn't make sense. It's a lot of investment, but it must meet these prereqs. So, as I said, such stringent requirements are valid only for unique industries, mental health care being one of them. All right, so I'll go into this deep dive here to explain how we built it. And we got really inspired by a few things from an architecture standpoint. The number one of that was just the password managers, your LastPass and all of those password managers out there. So their architecture. And then the second thing that we, from a why now standpoint, why it made sense was that encryption, decryption libraries on the client side, on the browser side, using JavaScript, became very sophisticated. There used to be a time that they were not on par with like the server-side libraries, or they were not performant, but like with time they got better, so we could utilize those. So let me go deep into this. So starting here on the left, we have our clinician who is interacting with our homegrown web application, the EHR application, to record their sessions, the therapy notes, and so on. Then as they save their work, it goes to the application server, which commits it into the database. So this is very standard 3-tier architecture we are all familiar with. We have a front end here and a back end there. So this is all very regular web app architecture. From here on is what I'm going to talk, what we started innovating on. So number one, we built capabilities to do encryption and decryption on the browser side. As the clinician works on their laptop, the browser has this capability to do encryption, decryption. That's number one. But to do that, we needed the keys, the encryption keys to be generated on the browser side as well. So we built that as well. And the most important bit was we trained our clinicians to use password manager. And believe me, this was the hardest part of the Vault architecture. To train the therapist to use password manager is not easy at all. So they would have their keys in their password managers, and they will interact with the web application normally, and that key would be used to encrypt any of the data that they were adding into the application. And then that encrypted data would go into the backend and eventually get stored on the database in an encrypted manner so that any of the internal privileged users, your sysadmins, DevOps, who have clear access to the database, even they don't get to see the data because it's encrypted by the keys held by the clinicians. So that's the most important bit. The keys are held by the clinicians. So the whole application is functioning well. Encrypted data, once it reaches back to the browser, it gets decrypted and shown. It's very transparent to the clinician, but it's completely protected on the backend. So this is all great, but this is not enough. If you put on your InfoSec hat, you will start finding all the corner cases that need to be accounted for. So the corner cases include, what if the clinician loses their encryption key, right? And it happens more often than not. What if the authorities come asking for the patient records and we can't say, hey, it's encrypted, we don't have it. That's our obligation to provide that record to the authorities. How do we handle disaster recovery? Like if data gets lost on the server side, how do we get it back? So all of these are extremely practical considerations that we had to account for. And as we built out the Vault architecture, we also had to build this other thing we call the secure enclave. The secure enclave is like a separate, what we call a macro segmentation of clear text data that gets stored in an offline database for handling all these corner cases. So I'll illustrate that a little bit more. So this is the slide from a couple of slides ago, the Vault architecture. Clinicians are working on the EHR app, everything is working fine, but we had to have a separate copy of the data. So how do we do that? So what we do is we have a separate account, a separate system we call the secure enclave, where every time the clinician saves data, it also posts to the secondary system, the secure enclave. And this one follows the principles of a one-way data valve, meaning that system can only be written into, there is no reads from there, it just pushes data into that system for offline use. So the secure enclave is extremely important to build out the Vault architecture. You can't have the Vault itself and not worry about the secure enclave. And then this secure enclave also had the basic data restore engine for handling all those corner cases. The data restore engine was highly restricted. It's completely offline, but it's available for in case something goes wrong. So together, the secure enclave on the left side and the Vault architecture in the online system gives us this confidence that we are doing our best to secure access to extremely critical clinical data. So internally, we fondly called this whole thing the cathedral and the bazaar. So on the left side, we had the cathedral database, the secure enclave, which is a very locked down offline database, highly restricted access, and it has some basic capabilities to restore data. And on the right side, we have the bazaar database, which is highly chatty. It's an online transaction processing system. It stores data, clinical data, but in encrypted manner, where the keys are held by the clinicians. And all the encryption, decryption, key generation, everything happens on the client side, on the browser side. So together, the cathedral and bazaar kind of help us build out the right architecture to securely store data. So this concludes my kind of presentation on the Vault. Some of you might have recognized the title of the slide, so I do want to extend my apologies to Eric Raymond, who wrote this book in early 2000, The Cathedral and the Bazaar, for a totally different construct of open source. So we somehow like the title, we are using it here, but apologies to Eric. Great book, by the way. So yeah, that's Vault architecture. I hope you got to appreciate how much effort we put in to make sure the patient's data is private, within the organization at Headspace, both from malicious insider as well as mass exfiltration standpoint. I will come to the last slide. The last slide is a summary slide to say what are the key takeaways from this presentation. So what can you apply? So in the next week, if you are working on building a privacy operations center that you should do within your organization, you should do a quick benefit, cost-benefit analysis to say whether the privacy operations center is required for your organization. On the technical side, if you think that your threat model requires investment into vault architecture, you should start working on that. In the first 3 months after this, you should, for the Privacy Operations Center, you should define partnerships across all different teams and departments in your organization, including your security, privacy, legal, compliance, product, engineering team, to say, hey, we need to come together to build out this Privacy Operations Center. Need to start working on the foundation of data classification, data tagging to say, okay, it's not like just the top level classification. We need to think one level deep because that's what will be so core to our privacy operations. And then if you are really like you say, okay, vault architecture makes sense for your organization, then you should, in 3 months, you should be in the kind of build, design kind of phase of that project and should have got the project funded. And then finally, in 6 months, if you have worked on Privacy Operations Center for 6 months, you should, by now, you should have a dedicated team to perform all reviews of new product features from a privacy privacy by design standpoint. You should have a dedicated training for internal employees highlighting the privacy risks and what they need to do, not just the security bits, but the privacy part. And then finally, like, if you are really invested in building your own vault architecture in 6 months, you should be in the middle of high activity build phase, ready to go live soon. That concludes our presentation about Headspace's work on Privacy Operations Center and the technical bits of building a vault architecture. We have few minutes remaining, so we will open for any questions you might have. Yes. Yes, so overall, the secure enclave, we are taking all precautions that we typically take, including data address encryption or not. But all data in the vault architecture, while at row level we had encryption for data by the clinician's encryption key. This one, the whole data was encrypted with one key. Yes.
How do you share accounts? Like, if you want to transfer data from one clinician to another one, how do you do that?
Yeah.
And also, like, when you delete something, how do you delete it in multiple places? How do you coordinate all that?
Yes. Yeah. Great question. Yeah. It didn't include. That's a second order question, but that's very important. We did take care of that. Essentially, sharing of data was important because we had this idea of a care team for a patient, right? It's not one clinician. We had like, for every patient, we had a psychiatrist assigned, therapists, couple of therapists, we had a bunch of coaches assigned, available to that patient for any of their mental health care needs. So that team needs to be able to share that. So at least in the clinical side, psychiatrists and therapists needs to share that. So we use this principles we learned from Google's way of doing Google Drive encryption. The key encryption key, the KEK thing, right? So key encryption keys were used so that we could have, for different clinicians, we could share those keys with that key encryption key. So that's how we were able to solve that. Yeah. Yes. Yeah. Yes. You want to take this? I'll take this. Okay. Yes, we are controller. We are collecting directly the data from the user. Even for EU citizens, from a GDPR contractual standpoint, while their employer might have the standard contractual clauses as the mechanism to share data, we had a separate contract directly with the patient when they onboarded, which granted them the GDPR rights, right? So for that, yes, all the data deletion, data modification, all of that was possible because of the secure enclave, where we had that other engine in the offline thing. So to kind of update, make corrections, delete data, all of that was taken care of because we already thought through all those corner cases while building this. Yeah. Yes. Yeah. Yeah. So the question is, if the clinicians are the controllers, then how are we managing GDPR? So I think maybe one point of clarification. All the clinicians are employees of Headspace. So they are not like, it's not a marketplace where they're using our product to run their practice. They are our employees. So the Headspace company policies kind of apply to all of them, right? So which includes the Headspace's ability to do these transactions on behalf of the clinician, including GDPR transactions. Yeah.
And just to add, there are specific guidance from HIPAA that you have to keep the PHI, and we can't delete the PHI. That is required by the HIPAA, that you have to keep PHI for a certain period of time. So even if, let's say, if I'm a patient and I go to Kaiser right now and say, hey, delete all my data, they'll be like, no, we won't delete your data because we are required to keep this for our own HIPAA compliance and so forth. And if there's a subpoena and somebody reaches out to Kaiser that, hey, I need all the data for Shobhit, Kaiser should be able to provide that data to the legal entity. They can't delete my data even if I have the rights of CCPA. Right. It's going to be one request. Yeah.
Oh, so the question is, how do you manage the encryption key? Like a very broad question. It's like encryption key management is every cryptography problem eventually ends up with the problem of how do you manage encryption keys, right? That's how it is. So for us, yeah, it was important. Like we had like encryption keys which were held by the clinicians. So we had set them up with the password managers. That's how they managed. Then we had internal encryption keys. We had key encryption keys and so on, which we built out the procedures of how to store them, manage them, rotate them from time to time. So all of that procedures were built out as part of this. It was a combination. Some of the keys we stored ourselves, but we did have Vault and all to, the commercial password manager Vault, the server side secrets manager Vaults. We had those as well. Yeah. Yes, sir.
Did you consider a tokenization practice as part of the Vault architecture at all? And if you did or did not include it, why or why not?
Yeah, great question. So the question is, did you use tokenization kind of? In some ways, you can look at all of this as tokenization. It's like, much like your credit card storage, right? We don't store the data, we get a token from like a Stripe, right? So this whole service for Vault architecture, in some ways for the application developers who were building our product, our own engineers, we had to retrain to think tokenization when we are talking about clinical data. Right, so they never got access directly to it.
That makes sense.
Yeah.
One more, if that's good.
Yeah.
With the bazaar and like the two-prong approach, would you say that's like industry standard in healthcare or in mental health space? Like, how, if you know, like how other people are doing it or anything like that?
It's not. We did our market analysis to first do a build versus buy decision.
Yeah.
We didn't want to build it, right? If there was a solution, we'd buy that. But unfortunately, and this is, by the way, dating back to 2018, 19, 20 kind of time when we invest. We've invested millions of dollars to build this, right? We didn't want to. But there was no solution. So we had to kind of invest in building our own. And that's why we are here sharing it, that, hey, if you want to, everything is here. We have some public documents out there about this architecture also.
Thank you.
Yeah. Yes, ma'am.
You said that the one visa request costs over $5,000. Where did that number come from, and have you seen any increase, decrease in that since you implemented all this?
There's a lot of research that I referenced. I'll be happy to share the exact link that I referenced to Process DSAR. And the reason why I wanted to have that number is we receive hundreds of those DSARs, hundreds of those. And if we don't have the proper processes within our end, we'll be spending maybe not that level of money, but pretty good sum of money just to process DSAR. That was the context that when we are planning to, or we are trying to have a DSAR process, we should keep the cost in mind because everything drives from there. So I did my research and that was the number that I came up with.
One other one.
Yeah.
So I see how all of this is wonderful. Well, I see how all of this is wonderful, period. But I also see how it's great from when you're working with brand new data and a brand new user and a brand new product. If I'm somebody who's thinking, well, I've already collected all of this data and I already have $100 million and I haven't done this tagging, do you have any advice for what to do with the mess that you already have out in the Like, what did you do? So
Yeah.
what you already have, and how did you get it from there to here?
We had to start somewhere. That was our thought process, that there has to be a better way. And if we don't do it on our own, and there was no industry guidance, I mean, all these regulations and NIST frameworks, privacy frameworks that we see, they are very, very overarching. They don't speak to this is how you should be doing for a telehealth company. And we didn't have a lot of guidance from other telehealth companies as well. So we did our best, and now we are definitely doing it retroactively for all the data. So when we have the data classification and labeling, it's not just that we are doing it only for the new data. That data is stored in a single database. So we are cleaning up the mess now. Maybe not as best as we can or we could in the past, but we are taking our own measures to do the best we can. Yeah. Yeah, so the question is, do we use any tool for automated classification and labeling? And then secondly, where do we store that classification? So when we started this process, we followed that 9-column architecture for all our inventory, and we didn't have a tool at the time. But now we do have a tool, and I can definitely tell you that after the talk. And we do use that, store all the classification in the tool itself that is tied to databases. So yeah. No, it's in the database itself, but the tool is taking data from the database, right? So even if I tag that in the tool itself, it will automatically tag in the backend as well.
And maybe I'll add to some of it is more easier, like to track it along with the data, which was our engineering team as they were writing new schemas and all, and that in the code, for example, in Python, they'll have these markups to indicate the classification. So that was right there as they were building new databases or new schemas. They started tagging the classification at the code level. But that's for what we are building, and that's not sufficient because we have data that we ingest from hospitals, we ingest from our employers. Those get stored in like SFTP, this, that, right? All of the. So over there, we have to take a different approach of classification, which is like tracking it externally in a tool that this data store has this classification. That's correct. Yeah, the question is in analytics use case, you need to kind of manage if data moves from one place to another. How do the classification move? So that's managed in this tool that Shobit was talking about. Yeah. Out of time. Well, thank you. Thank you so much.
Thank you everyone.